25 students of a class appeared for a test. Their marks were recorded and mean was calculated using direct method. So the very first thing we did was to calculate Fi into Xi. It was calculated, and since this is the formula for mean, we found out summation of Fi into Xi, which is 1995. And since we know that there are a total of 25 students, the mean came out to be 79.8. But later it was discovered that one of the questions in the test was incorrect, and therefore 5 marks were awarded as a bonus to every kid. Now, the updated marks became 69, 75, 80, 85, 95, 98. Now, what do you think would be its effect on the mean? The mean would increase, and if it does, by how much? Let us look into it. Since now the values of xi have changed, the values of fi into xi would also change. So this would be 69, 75 into 4 is 300, this would be 560, this would be 425, then we have 570, and 98 into 2 is 196. Let's calculate its total, which is 2120. Now the updated mean would be summation of fi xi upon summation of fi, which is 2120 divided by 25. And this comes out to be 84.8. So we see that when we added 5 to all the data's values, the mean has also increased by 5. 79.8 plus 5 is 84.8. So can we say that if x is added to each data value, the mean also increases by x? This is in fact true for multiplication as well. If x is multiplied to each data value, the mean increases x times. Let us see the logic behind it. Let us say we have 5 data values, x1, x2, x3, x4, x5. Its mean would be sum of all observations upon total number of observations. Now we have added a specific constant, let's say 5, to all the data values. So this is a new data set. Its mean would be sum of all observations, x1 plus 5 plus x2 plus 5 plus x3 plus 5 and so on, divided by 5. So the total number of observations is still 5. This would be x1 plus x2 plus x3 plus x4 plus x5 plus 5, 10, 15, 20, 25. And we can write it as this: x1 plus x2 plus x3 plus x4 plus x5 divided by 5 plus 25 divided by 5. And this is nothing but the original mean. So the new mean is original mean plus 25 divided by 5 is 5. Right. Let us check this for multiplication as well. Let's say we multiply 6 to all the data values. Now the new mean would be 6x1 plus 6x2 plus so on divided by 5. We can take 6 as common, and then we see that this, the value written in this yellow color, this is the original mean. So new mean is original mean into 6. We see that if each data value in a distribution is, this is true for subtraction and division as well. So if each data value in a distribution is added, subtracted, multiplied, or divided by a constant, the mean will also be added, subtracted, multiplied, or divided by that same constant. This helps us understand how data transformations affect the statistical summary. For example, let's say we have some data set where we have been given data in rupees, but we want to do currency conversion, we want to convert it into dollars. So we do not need to find the mean all over again. Since each data value will be changed by a particular constant, we can straight away use this and find the new mean. Let us also see how this change, this transformation affects median and mode. We have the same data set. Let's first calculate the median for this original data. We need to find cumulative frequency. 1, 4 plus 1 is 5, 7 plus 5 is 12. We did this. Now our n over here, the sum of frequency is 25. Since it is odd, we know the formula for median is n plus 1 by 2th observation. 25 plus 1 by 2, that is 26 by 2, 13th observation. The CF which is just above 13 is this one. So the median marks are 80. Now when we update the marks, this becomes 69, 75, 80, 85, 95, 98. We see that there's no change in frequency, hence there's no change in CF. Right? N is still the same, the formula is still the same. We still need 13th observation, which is again this class. And now the new median is 85. So if each data value is increased by 5, the median also increases by 5. So this is true for median as well. If x is added to each data value, the median also increases by x. And it is true for multiplication, division, subtraction as well. Let us look at the effect on mode as well. So we have the data. Mode is the highest frequency, right? So it is this one. Mode in this case is 75 marks. Once we update the marks, mode would still be the one with the highest frequency, which now is 80. So once again, if x is added to each data value, the mode also increases by x, and same is true for multiplication, subtraction, and division as well.